After it has installed a package or anything you wanted to import, it is going to update the Python interpreter and the indexes, so everything stays up to date. You don't have to change anything. So let's carry on. Now we are going to remove all the punctuation marks, which is quite important to do. So review dot replace. So this is really tricky, so just bear with me. You can copy the whole thing, but yeah, slash word slash small. Yeah, I think this will work fine. Let's hope. Then after that, as the bigger the sentence, the more time it will take to process it. So we are going to break down everything into smaller sentences so it is easier for us. And smaller sentences, I mean tokens. NLTK dot everything working fine till now. Let's add some stop underscore words is equal to set dot words English. Good. Now let's write a function to remove all the stops. Let's give it a name row, my list array. It will contain everything. Words meaning full words is equal to w for w in list, if not w in stop words. Good to go. Then we will return everything which we want, and this is going to be meaningful words. Bingo. Df target is equal to df dot apply remove stops, removing all the stops excess. The it is going to be one dimensional. What the fuck it is doing again? Error. Hmm. Stop words. Good. Good. Yeah. Let's carry on. Streaming is equal to port stammer. So a lot of you might be wondering what Porter stammer is. So the Porter stemming algorithm is a process for removing the commoner morphological and inflexible editing from words in English. Its main use is to part of a term normalization process that is usually done when setting up information retrieval systems. I hope that's understand. I'll give a link to a very beautiful article and you can read more about this. To be honest, I don't really know much about this. This was talked a lot in our class. So another function, exact same thing, just for the Portis timer. So I'm going to copy this thing and everything should work. Yes, it is, no errors. Moving on. df dot apply stem list c1 training df dot sample frac 0.8 random state is equal to 200. No, sorry, 2000, not 2001. So this is the training set which we will be keeping to train our program. Frag 8 means that only 80% of the data will be reserved for training and the 20% will be test. Test is equal to df dot drop train dot index. This is our test set. Training set. Train for train dot sentiment is equal to positive. This is training set with positive sentiment. Train. This is for the negative training set with negative sentiment. Now probably the last function of this files, def show word cloud train underscore examples title will be none, we don't need that check. Word cloud, yeah, background color black. No jokes. Maximum words is equal to let's say 10. Yeah, and we need font clearly visible 40. Scale will be 3. Random underscore state is 1. Then dot generate, yeah, str, come on, train. So this random state, the random state is chosen at random by flipping a coin. That's going to train this data. It will be choosing anything random, so there's no given set. And then we'll plot a figure 1. Fixed size will be 15 by 50. This will be the chart. plt dot access, it is going to be off if title fig dot subtitle title font size 20 fig dot subplots adjust top equal to 2.3. Yeah, plt dot I am show word cloud plt dot show train pause. This will be review, and this will be for negative. Sorry, nag. Everything working fine. Everything working fine. Are there any errors? Anything? Nah. I think it's alright. We can move to the second thing. So now, after you have made this, we are going to use Markov chain. So ignore this. It is going to happen because we have only reserved the data and we have not worked. So we are going to use Jupyter notebook to do this, and we are going to call it Markov chain. Boom. What? Yeah. So look, when you first start a Jupyter notebook in PyCharm, you have to install a Jupyter. If you have not already, I have got Anaconda, but I don't need one. So PyCharm will automatically install that for us. Let's just click on install and look, it has started to install. So let us give it some time. It always takes time, and then after that it will start indexing and everything. So till then, what is Markov chain? So the definition on Wikipedia is a Markov chain or a Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. A countably infinite sequence in which the chain moves state at discrete time steps gives a discrete time Markov chain. A continuous time process is called a continuous time Markov chain, and it is named after Russian mathematician Andrei Markov who have made this. And I need to show you one more thing. It has started to update the interpreter and have started to install all the packages. So it is good for us. This is a Medium profile where I am currently writing that article for this thing, and it will be published after I have completed it. So you can find to check it and follow. What? Yeah. Why is this happening? Successfully installed. Good. Updating indexes. Good. So now let's start coding. First of all, we need to import CSV, import pandas and PD. So as we have already imported these things previously, so we don't need to import everything one by one in this again. Import numpy, np, import NLTK from NLTK dot, and here is a really nice thing. So in Anaconda it won't tell you what, but here, as it is a proper well developed IDE, it will give you suggestions what you might want needed to import. So it's really nice. Look, it automatically completed everything, so it saves a lot of time. From NLTK dot corpus import stopwords.